Are we entirely alone in the dark, or is our ultimate destiny waiting for us just right next door? Welcome to today's Explainer. We're going to jump right in and unpack one of the most profound existential mysteries of our time. We are looking at a world that is hauntingly familiar, but honestly alien beyond our wildest imagination. We're talking about a place that might literally be humanity's first stepping stone into the wider galaxy.
Okay, let's dive into this. Because, for the entirety of human history, our survival, our whole evolution really, has been completely defined by pushing out into the unknown. But what actually happens when you just run out of map? What happens when a species that is literally built for expansion hits the physical limits of its homeworld? This isn't just about exploring for the sake of cool science. This is a massive question about our long-term survival and our ultimate destiny as a civilization. Astrophysicist Brian Cox hits the nail on the head here. He points out that our growth completely depends on finding a cosmic frontier. And while we've pretty much exhausted our earthly one, think about it. The benefits of operating as a civilization on the edge of the unknown, that's exactly what drives our technology, our culture, and our survival forward. If we're going to keep expanding, we can't just stay put here forever. We have to look outward to the rocky planets out there that might just offer us a second home. But hold on. Before we can even ask if life or, humanity could exist out there, we have to figure out if the building blocks for this new frontier even exist in the deep freeze of space. Like, are the ingredients for life just some miraculous earthly anomaly, or are they actually scattered out there in the dark? Well, recent discoveries right here on our own cosmic backyard have given us a pretty shocking answer.
Now, what's really interesting about this cosmic recipe is just how staggering the findings are. When NASA's OSIRIS-REx mission brought back samples from the asteroid Bennu, they didn't just find a bunch of lifeless, boring dust. Not at all. They found abundant water, ammonia, and get this, 14 of the 20 essential amino acids used by life on Earth. Plus, crucially, all 5 nucleobases you need to actually encode DNA and RNA. This basically proves that the raw chemistry of life is practically floating everywhere. The universe is literally primed for it. So, okay, the ingredients are out there, but where's the nearest kitchen? How far do we actually have to go to find a rocky planet that might have cooked up an environment we could inhabit? The answer is 4.4 light-years. That's the exact distance to our closest interstellar neighbor, the Alpha Centauri system, and specifically its small, faint star known as Proxima Centauri.
Now, to truly grasp the stakes of this whole cosmic journey, we have to appreciate the staggering, awe-inspiring scale of that void. 4.4 light-years might sound like a quick hop in astronomical terms, but let's put that into perspective for a second. If you were riding aboard the Voyager spacecraft right now, hurling away from Earth at a blistering 17 kilometers per second, it would still take you over 70,000 years just to cross that gap and reach this neighboring star system. 70,000 years. It is a monumental, almost incomprehensible distance.
But despite that insane vastness, human ingenuity has allowed us to peer across the dark, thanks to an observational campaign brilliantly named the Pale Red Dot Initiative, which is a nice little homage to the famous pale blue dot image of Earth. Astronomers managed to pinpoint our very best hope for a second Earth right next door. They actually found a planet orbiting that neighboring star. Let's look at the tantalizing specifics of this world, Proxima Centauri b. It's a rocky, Earth-sized planet, and most importantly, it sits squarely in the habitable zone. The Goldilocks zone where liquid water could actually exist. But check out that orbital distance, 0.05 astronomical units. That's just 5% of the distance between the Earth and our Sun. It hugs its host star much, much tighter than Mercury hugs our own Sun. Honestly, the only reason it doesn't instantly vaporize is because its star, Proxima Centauri, is incredibly dim compared to ours. Let's move to the star itself and see how this builds, because this is where the dream of a lush green second Earth hits a brutal wall of reality. Proxima Centauri is not a calm, stable yellow dwarf like our Sun. Not at all. It's a red dwarf, and man, that comes with a horrific set of challenges for any planet just trying to survive in its orbit.
See, red dwarfs are small, but they are incredibly temperamental. They're prone to these massive bouts of cosmic rage. They can develop star spots that cover up to half of their entire surface at a single time. And worse, they regularly erupt, flooding their local environments with violent electromagnetic plasma storms. This absolute barrage of extreme radiation threatens to basically strip away the atmosphere of any planet that gets too close, constantly alternating between periods of extreme cold and these massive bursts of intense roasting radiation.
And because Proxima b has to orbit so incredibly close just to stay warm, it falls victim to a gravitational trap known as tidal locking.
It's exactly like how our moon only ever shows one face to the Earth. Proxima b is forced to permanently show only one face to its host star. It's a total planetary nightmare. You're looking at a world where the sun literally never sets on one side and never, ever rises on the other.
And this brilliantly illustrates the horrific dichotomy of this planet. On the day side, you've got this eternal, scorching desert facing the direct, unending glare and violent radiation of the star. And then on the night side, a pitch-black, catastrophic frozen wasteland, completely locked in perpetual deep space ice. I mean, neither side sounds remotely survivable for a civilization looking for a new frontier, right?
But here is where the story takes a super fascinating turn. Right between the absolute hellfire of the day side and the catastrophic freeze of the night side, there's this tantalizing sliver of hope, a physical boundary line that separates these two wild extremes. We call it the Twilight Zone, or the Terminator line.
So, the crucial point is that this phenomenon creates what the legendary science fiction author Arthur C. Clarke originally coined as a ribbon world. It started as a pure sci-fi concept, but computer modeling now shows it could be absolutely real. A ribbon world is a planet that is habitable only along that narrow, continuous strip girdling the planet. In this really thin twilight ribbon, being heated from one side and cooled from the other, the temperatures might actually find a perfect, stable balance. But keeping this twilight oasis alive requires some incredibly precise mechanics. First off, the planet must have held on to its deep oceans and a thick atmosphere despite all of the star's tantrums. Second, that atmosphere has to act like a giant planetary conveyor belt, circulating the intense heat from the day side all the way around the globe. And third, the night side's atmosphere can't be allowed to freeze completely and catastrophically collapse onto the ice. If all these mechanics balance out perfectly, life could absolutely thrive in an eternal twilight.
Which brings us to the ultimate question for today's explainer. If we actually do cross that 70,000-year void to expand our frontier, what would a human civilization even look like if it lived on a ribbon of permanent twilight, forever wedged between fire and ice? I want you to head down into the comments and debate this right now. Could humanity really adapt to an eternal sunset on a pale red dot? Or is a ribbon world just a giant cosmic trap? Let me know your thoughts down below. Make sure to subscribe for more deep dives. And as always, keep looking up.